Good morning and welcome everybody to today's webinar on transforming Europe's district heating and cooling networks. My name is Emilia Pisani and I am project manager at RISE, Research Institutes of Sweden, and I have the honor of being the moderator for this session. Before we get started with the interesting part, I need to cover a couple of basic housekeeping points. This webinar is being recorded, as you may have noticed, and will be uploaded to the Euroheat Power YouTube channel. So you may go back to it in case there are any points you want to see or share it with your contacts who believe may benefit from such a session. Thank you all for taking the time from your busy lives to connect to this webinar. We hope you'll come out inspired and engaged. And this is why we strongly encourage you to engage with our speakers and make it as interactive as possible. So please don't hesitate to ask your questions or make some comments by using the Q&A function at the bottom. So before we move forward, for the speakers and I to get a better idea of who we're talking to, can you please go to the reactions button, send us if you like a little like or a little reaction if you are involved in any of the projects being presented today. Can you do that? Yes, no, maybe so. Not so many reactions. So I believe it's not on you, it's on the software. Anyway, so now let's get to the heat of the subject. Given the geopolitical situation around the world, which personally feels like it's getting worse and worse every day, I believe we can agree there's an urgent need to transition away from fossil fuels and build a more sustainable and secure energy future for Europe. The European Union is in a unique position to lead the way. Heating and cooling sectors plays a significant role in our overall energy consumption. I mean, depending on the sources, it represents between 70 and 80% of the energy demand in building sector across Europe. This sector uh, it has a considerable yet crucial challenge and much needed energy transition. This webinar, brought to you by the DH Synergies Hub, is dedicated to showcasing some truly innovative solutions that are already making a difference. We are 7 projects that you can see on the screen now with a common cause. So instead of working in silos and away from each other, we have decided to join forces in the hopes that together we will have a greater impact and really drive this energy transition forward. Over the next hour and a half, we'll be exploring these exciting projects across Europe, each offering a unique perspective on how to decarbonize district heating and cooling networks by facilitating the integration of low-grade or residual or waste heat into existing district heating networks. We'll learn about their varied approaches, examine how they're tracking in unique challenges associated with different geographical regions and energy landscapes. We'll not only learn about the technical aspects of the project, but also gain insights into the crucial policy and financial considerations involved in their implementation. Because once you have the technique down, you also need the policy, the investment, and the stakeholder engagement to make it possible. There are barriers to overcome and many lessons to be learned. So, as you think, I would like to ask you to think about the experience and potential success of these projects and how they can be replicated across Europe in your own spheres. We're fortunate to have a panel of leading experts joining us today. Really exciting, you'll see. And I encourage you to actively participate in this Q&A session. Here it goes again. Do engage with us. So without further ado, let's begin exploring those exciting solutions and discover how we can transform Europe's district heating and cooling networks for a greater tomorrow. We will start with the Life to Heat Set Heat project presented by coordinator Jacek Kalina, associate. Thank you. Professor Jacek is associate professor at the Silesian University of Technology, where he graduated in 1997. And since then, he has been working in the field of energy systems engineering. He has experience in the fields of power and cogeneration plants, small-scale cogeneration and trade generation, modeling of industrial thermal and flow processes, utilization of waste energy and industry, economic problems of construction and exploitation of energy conversion plants, technico-economic optimization of thermal energy systems, energy management, policy, and market studies. Professor Kalina is the manager of several research and development projects financed by different national and European public institutions, as well as industrial institutions. So please, Jessica, the floor is yours. Can you tell us a little bit more about the SET Heat project?
Thank you very much, Emilia. The bio was very impressive when I heard it. It was very interesting. Hello, everyone. I'm coordinator of the SET Heat project, as Emilia said, and I have a pleasure to start this webinar. At the beginning, I would like to say that this is quite a unique experience you are experiencing now, because in my opinion, it's the first time where 7 projects join together and collaborate on a topic. So that this is quite interesting how this collaboration will end up. But anyway, we started and we are very excited to continue. So I have a pleasure to present the SET Heat project. Title is Supporting Energy Transition and Decarbonization in District Heating Sector. So the project has very briefly, we work with 4 district heating companies. In total, we have 12 partners in the project, but 4 are key partners. These are major players in district heating sector in 4 countries, Poland, Lithuania, Romania, and Croatia. These are big district heating companies. And we are working on investment plans to integrate low-grade heat sources into the existing high-temperature networks. So it's a quite big challenge. We are working on this. We've been working on this for about a year and a half. And what is the goal? At the end, we want to trigger strategic investment programs. So we want to trigger actually a real change in the district heating sector. And this real change will happen through implementation of a series of tangible projects. So every project is something materialistic, but not only this is very important for decarbonization and energy transition. So actually, we are working on many aspects of the subject. So the project represents a holistic approach. And in fact, it's a huge challenge for the district heating sector. At the moment, in most of the cities, we have centralized systems with single or 2 or 3 heat sources and large district heating networks. And this is going to change because when we try to harvest available energy locally, we see that the composition is something obligatory, reconfiguration of the systems. So we will have distributed sources, so we'll have multiple sources. In some cases, this number will change from something like 1 to 25 in couple of years, in very short time horizon. So it's a huge challenge. Some of the sources are intermittent, so you have heat only for certain hours in the year or in the month. Then heat storage is something obligatory. Huge territorial expansion. This is quite an important problem because district heating systems have no access to terrain locally. So they must work with municipalities, they might work with landowners, etc., etc. And there are many, many other issues. So this is not only the technical challenge. Technology is one part, but this is also huge economic and social challenge. And we are trying to cover this in a holistic manner. So at the moment, we are starting, let's say, specific projects, but to implement this project, we need something like a strong foundation. So we are building this foundation, we are triggering cooperation with stakeholders, and this is I must sum up because we've been working on this for 18 months already. So this is problematic to build this strong foundation for effective energy transition and decarbonization. So we have applied also some, scientific methods, and we selected, we call it model investment projects. Before we did that, we made a screening of potential replicable projects. And what you see in this slide is our conclusion about replicability. So what projects have the highest potential? So as you see, the most attractive for this are water source heat pumps. So whenever or wherever we have water available as a heat source, we should look on this. But on the second place, we have air source heat pumps. And on the third, we have flat solar collectors. So these are three main technologies. And then we go to some smaller and also large seasonal heat storage. This is something that must be implemented in district heating sectors to harvest all available heat from local resources. So we have defined 6 model investment projects. These are like sub-projects in the ZHeat project. So we have the first one is ZHeat sewage. This is a project that is focused on heat recovery from treated sewage or treated wastewater in cities. Then we have ZHeat retail. This is a quite important project that focuses on heat recovery from large supermarkets. Then we have ZHeat water. So this is focused on heat from, let's say, surface water sources like rivers, like lakes. Then ZHeat air. This project will prepare a model air source heat pump project, and then ZHeat solar, and at the end ZHeat peat thermal energy storage. So all this project will be addressed with pre-feasibility studies, so-called ready-made documentation that the companies can later use for, let's say, speeding up the application for funds. And we hope this will be successful. And that's it. Very quickly, I came to the end of my presentation. So you have a lot of contact information at the end. At the bottom, you see we have a social media like link in YouTube, Facebook, Twitter, or X platform at the moment, and Instagram. So you can follow us and see what we are doing. Thank you very much.
This is great. Thank you. And it is bittersweet. It's very frustrating that the presentations about each project are so short, but we have so many projects that the hopes is that we will engage in the discussion. And if you're interested, please do contact the project coordinators, the speakers, to learn more, and so you can engage in a further, deeper discussion with them. We actually have a question from the audience. Thank you, Paul Coopers. Why don't you look at using heat from data centers?
We are also looking at it. Data centers are very important. First of all, data centers are not everywhere. So in locations like, for example, in Poland, in Polish cities, in Romania, in Croatia, we have less data centers than in other countries. In Lithuania, we have already a project under implementation. So it's ongoing, and we will have, it's quite similar to supermarkets, because when we speak about data centers, we always end up with the project that recovers heat from cooling systems. So when we see supermarkets and we see data centers, so technically these projects are more or less similar. There are many examples of using heat from data centers in Europe. This is why we decided to go for supermarkets. And this is why we developed, because this is something that everyone knows, that we can recover heat from supermarkets, but only in northern countries like Denmark, Sweden, Finland, they do it at, let's say, reasonable scale. So we want to, for example, identify some obstacles, some barriers in other countries like Poland, Croatia, because recovering from supermarkets, for example, in Bucharest, Romania, this is very important source of heat. And we would like to address it, but no one knows how to do it. First of all, we have to start with stakeholders, and we see, for example, because this project is developed in Vilnius, and they approached owner of large network of supermarkets, and this is quite important. The first step is a biggest problem: how to start this project, how to trigger development, and we are at the moment in this project now.
I think you point out a very interesting thing, what we call innovation, right? What's innovative in one country and not, and how do you adapt it? And as you said, how do you do it at a important enough skill that it really makes a difference. I have two more questions, so I kindly ask you short answers so we have time for all the other speakers. So from Nick, I'm not going to say the last names because I will just butcher them. Why are you only looking at a treated wastewater? Why not wastewater while still in the city? And he provides a link looking at appliedenergyplanning.com.
Because in big cities, our strategy is to look at the low-hanging fruits first. And from concentrated sources of wastewater, like sewage treatment plants, we can recover from 5 to 40 megawatts of heat. In Bucharest, for example, entire city has one sewage treatment plant. And in this place, we can install around 150, because this is one sewage treatment plant for almost 2 million inhabitants. So we can install around 150 megawatt heat pump. So it's a low-hanging fruit. If we distribute this into very small projects related to, close to buildings, etc., that won't be such, let's say, economically effective. Of course,
Great.
it's option, but I said low-hanging fruits first.
Thank you. Then we have a question from Jacek, but I will save this question for the end because I think it's applicable to all the projects. So having said that, I thank you very much for your time and presentation and look forward to continue the discussion at the end of the webinar. But now I would like to continue with Support DHC project presented by Dominic Rutz, who is head of the unit at WIP Renewable Energies since 2005. Dominic, are you with us? Great.
Yes.
You are an expert on renewable energies and specifically on bioenergy, bioeconomy, and renewable heating and cooling. You're currently coordinating 3 GEO projects, so Support DHC and Skills for DHC, which focus on district heating and cooling. SIB focuses on life cycle assessments in the bioeconomy. So, Dominic, what can you tell us about the Support DHC project and what makes it unique?
Many thanks for the kind introduction. Hello to everybody. And starting with the good news, we have a case study on the data centers. So I will say a few words about that in a second. So it's a pleasure to present you the Support DHC project. Before I do that, I would like to thank especially Laura Yunasova and the team from Here on Power for making the hub, but also for organizing the event today, even though they are not here on the stage today with us. So let's dive into the details. I'm checking the facilities. Yeah, like Support DHC is one of the live projects. We are in the middle of the project, similar to the other projects that are presented today. And the objective is to trying to provide support for the integration of renewable energies and waste heats in district heating cooling, as it is similar probably for the other projects. We are focusing also on the investments plans, but trying also to give some hints to the transformation plans, which are the broader, more long-term plans of the operators for changing their district heating and cooling systems. So these are the countries where we focus on. We have 6 countries: Italy, Austria, Germany, Poland, Lithuania, and Ukraine. And these are the project partners. So the project is coordinated by WP Renewable Energies. We have also the German District Heating and Cooling Association, AGFW, in Germany. We have the University Politecnico di Milano from Italy. We have IINTEC and eThink from Austria. We have the Cities Network, PNEC, in Poland. We have the City Institute in Ukraine. We have the Lithuanian District Heating and Cooling Association. And we have Planenergie and Halmstad University as supporting partners. Our approach is that we focus on so-called frontrunner DHC cases where we have intensive support for operators. We want to use this knowledge to support also some further DHC operators, the so-called follower cases, and then we have a replication program. So we focus on the work package 3 and 4 for supporting DHC frontrunner cases and follower cases. We also have a capacity building program and some other work packages that are common to these kind of projects. So let me quickly go into the frontrunner cases. You don't need to read everything, but this is like the baseline for our work. We have Kapfenberg in Austria, where we are trying to focus on power to heat systems, also the use of some waste heat from industries. Then we have the DHC system from Frankfurt together with the operator Mainova. And here we focus on the data centers, how to use the waste heat from data centers. There are some more data centers popping up in the region, so that is highly relevant, but also not so easy as we understand. But we came up with a calculation tool to calculate the economics of the waste heat integration from data centers. So that may be relevant also for the other projects. Then we have 3 cases in Italy, in Lodi, Cremona, and Reggio Emilia, where we focus also on wastewater treatment plants and the use of that energy. We have Alytus from Lithuania, where we focus on absorption heat pumps and also flue gas condensation from biomass systems. In Kaunas, we have the focus on heat pumps and also on the flue gas condensation. The Polish cases are quite different. So in Kotczynice, we focus on replacing coal and also connecting a waste incineration plant. In Zakrzewsko Kamienia, we focus on the reduction of temperature levels in the system. And in Stettin, we are looking for the large-scale heat pump integration using energy from river. In Lviv, in Ukraine, we are very proud to have also the Ukraine case in our project. We try to reduce losses, increase efficiency of the system, and of course the security of supply on district heating. That's highly relevant. So I think the impact, we support close to 40 DHC operators. We also have some capacity building measures. We would also like to improve regulatory frameworks or to provide some help here on the administrations. And we would like to reach out to many stakeholders, of course. So that's in a very nutshell about our project. And I'm happy to answer some questions.
If I mute myself, you might hear me better. So thank you very much, Dominic. And also want to point out, thank you for pointing this out, the great work that has been done by the European Power team. and Laura. I see Goal Anubab has the hand raised. I kindly ask you maybe to write your question in the Q&A. It might be easier to interact. While you do that, I want to ask Dominic, what are the most important results and achievements in the project so far? What do you see has the most promising impact?
Well, as I mentioned, we are in the middle of the project, so support activities are going on. I think what is very interesting is, of course, the case of Frankfurt and the use of data center waste heat. That's very good, but I can't tell a lot more about that. And the other action or highlight I would like to raise is that in Italy we had some capacity building measures already, so some courses with stakeholders and operators. And as a result, some policy stakeholders from the region of Emilia-Romagna signaled interest, and they are thinking now about introducing a local legislation on the district heating and cooling. I also can't say a lot more about that at the moment, but I think like if that really turns into a reality, that will be a very good and nice result.
When will people be able to learn more about it and where? How?
Well, the main publication we will have will be in September. So until then, we do the job, we do the work. We are very careful in sharing some data because we are working together with the operators, and some of the data and results and discussions are confidential, as you may imagine. But I mean, people can always approach me bilaterally, and then I can say as much as I'm allowed to say.
So there you go. Two questions. Write to Dominic. Stay tuned. And I think here we might have a subject for our next webinar, because the idea is that we have these types of webinars at least twice a year, all of us together to share the results. So do stay tuned and sign up for the newsletter if you haven't done so already. So this is really exciting. More to come. Unfortunately, we do need to move on as time will not stop as much as we would like it to. So we will now learn about the low to high DH project, presented by, waiting for the transition of slides. Great, thank you. It is presented by David Perez, partner at Creara. David holds a double degree in law and economics and business administration. So there you go. With over 20 years of experience in renewable energy and energy retail, he specializes in regulatory, economic, and strategic analysis, as well as financial assessments for public institutions, investors, manufacturers, and energy retailers. He has served on the boards of key industry associations such as UNEF, ASIF, Alian, ASIT, Cogen, and Proterno Solar. He has led strategic projects in European energy markets, including acquisitions of corporate strategy and market regulation. In the Life L2HDH project, he oversees management, resource allocation, and progress, driving the decarbonization of 30 district heating sites in Lithuania, Poland, and Slovakia. So, David, it is really an honor to have you here, and we look very much forward to your presentation. So, tell us, how is the low to high district heating project helping transform the networks for a sustainable future?
Thank you very much, Emilia. Can you hear me? Yes, it looks like you can. Thank you very much for this kind presentation. Yeah, what I'll do is explain what we are doing in the project, which our targets are, and well, explain how things are organized. That's it. This is just the agenda. Yes. So the Low to High project focuses on Lithuania, Poland, and Slovakia. Something which is important is that my two colleagues mentioned before, it is this goal wanted to investigate and research about low-grade renewable sources. I mean, this is something which is important, and also waste heat, of course. This is something very important because, as most of the audience, I guess, know, I mean, introducing biomass in district heating systems could be, let's say, something straightforward and relatively easy. But the challenge and the difficulty is not to include biomass and look for other sources, which are maybe more scarce and more technically and economically, as Jacek and Dominic mentioned, more challenging. No, these low-grade sources, which could also be called as low-temperature sources, is what is the challenge. No, and this is what we'll try to look for, and we'll try to integrate in the existing district heating systems. Of course, heat pumps will be also key. This also is not a secret, because in I would say all cases, heat pumps will be needed to integrate these low-grade sources. The project will last for 3 years, as I guess all live projects. We have been funded with 1.4 million from the European Commission, and we are focusing on essentially 10 projects, 10 sites, which we call pilots, and then another 20 what we call replicants will follow, trying to leverage from the experience we will gather with the first 10 sites. These are the partners taking care in the consortium of low to high. Creara, which I represent, is the coordinator of the project. We have a partner specialized for financial analysis, which is G&E, placed essentially in Spain, but with low experience in European projects. Our communication dissemination partner is Euro Project, which is a company based in Bulgaria. And then we have 2 technical partners, which are Italian universities from Genoa and from Naples. And then, very relevant, the 3 country partners, which is in Lithuania, the Lithuanian Energy Institute, in Slovakia, the Stuba, which is the technical university of Bratislava, and in Poland we have KAPE, which is the official agency for energy in Poland. All of them have a long experience, and their members, their staff has long experience in district heating industries, specific cases, transformations, etc., within and regulation within their respective countries. So what we are going to do with this site, essentially, we're going to help them to develop these investment plans. These investment plans should be, we see them as documents which will help them. First, we'll describe the technical solution, whatever it is, and then these documents should help them to find the money, essentially, to transform their sites. So essentially, first we'll have a technical plan that will include renewable sources and also the technical solutions to harvest these sources. Then financial planning, this is very important. So looking at all the economic side of these technical solutions, that includes investments and operating costs. And after that, of course, try to see what the economics of the district heating site would look like after the investment has been done, and how can that be financed by external sources. That could be public monies or private monies. That could be regular funds, regular banks, could be also subsidies from European institutions or even national ones, and of course investment funds that could also play a very relevant part there. And then we will have them also to put all that together in a document and go out there and try to find the money and the plan to finance these investments. Something which is, I guess, different in low to high from other live projects is that we made a call for applications. That means that when we built the proposal, we didn't have the sites already decided which district heating sites or companies were going to be supported. So what we did is organizing a call for applications. So essentially, we looked for sites who wanted to be supported in this process. And that is something we did last year. The call was open for a couple of or 3 months, something like that. And then we made like a selection of the most relevant or appropriate ones to be selected. This implied that our work with the sites started a little bit later than in other projects. So we are essentially now starting to work with the sites, trying to find the renewable sources, technical solutions, etc. But we hope to have now we have selected these 6 sites in the 3 different countries. We have to select 10, but the first call for application is closed now. So we're going to start working with these 6 you see on the screen. We received 32 applications from the 3 different countries. And of course, we will open a second call for applications to complete up to 10 sites to be supported. And then the rest of the sites, the replicant ones, which will be 20, will be selected based probably will be picked from these 32 plus the new applicants we will receive. So mentioned slightly in a previous slide, essentially this is what we are trying to do and the impacts we are trying to reach. So essentially on the technical side, we will focus on methodology and tools. Essentially, we will help the sites to understand how to find these sources and how to build a system which reduces CO2 emissions using tools that maybe they don't use day by day. Second, so that will imply helping them to improve their skills. Second, the demonstration, of course, very relevant on the technical and financial feasibility. And this is a work we will run together with the country partners and with the sites themselves. Of course, along the process, we will identify which are the barriers, problems, issues with regulations, which will be some, as we have seen already. And therefore, we will try to address them in a document so that the regulatory framework of the country will be improved after this exercise. And with all this, our goal is to essentially replace 1 terawatt-hour of fossil fuel per year out of these sites we are going to support. And that's it. This we are starting the work as I said, and I hope to make a very good progress and being able to report success stories within 6 months or 1 year or something. Thank you.
Thank you. I see a question here from an unknown participant who's wondering what kind of projects are being analyzed in Slovakia.
What kind of projects? I mean, we are selecting in all cases district heatings, which fits with the criteria selection criteria we put forward. So essentially, we wanted to we selected sites using essentially only fossil fuels, which enough size and which have let's say which are ready to be helped. I mean, they should have available data. They should have enough personnel to have discussions and to study the case, etc. But about the specific cases in Slovakia, well, I would ask this person making the question to send to contact us within 3 months, 6 months, so that we can give further details.
Could you show a slide with the details where they can contact you?
I don't think we included a slide with contact details, and I can't. But I mean, if you go to the website of the project, there are contact details over there. I mean, we don't have a slide with the contact details specifically on this presentation, but on the websites, you have everything.
Right. And then really, really quickly, why were not the DH sites to be supported by the project selected from the very beginning? Why did you decide to do this call for applications and yeah, doing this process now?
Yeah, that was a methodology we have used in other projects, also about district heatings in the past, and that worked pretty well. So we decided just to use it. Also, that sometimes when you prepare the proposal, sometimes you don't have the time to look for the best sites. You just go and get what you have, what you find. So this allowed us to really pick the ones which are more suited and in a better position to be supported. So we hope that this provides a better working environment, and we hope to go faster in the analysis with these sites.
Great, thank you. So once again, let's stay tuned and see the result and see the compare notes, and that one's one of the purposes for this. So I would like to continue with the next project, which I believe is Enable DHC. And it is to be presented by Riccardo Battisti, who is a senior researcher at Ambiente Italia. You have worked with management and development of European and national projects with local authorities, industries, associations, universities, and research centers. Many of you know him. He's been with Ambiente Italia for over 17 years, so I think that's a great track record. And it'll be very exciting to see his perspective and take on this new project. So, Ricardo, please, how can you enable strategies and investment plans for efficient district heating?
Thank you, Emilia, for the introduction, and thanks also to Euroheat and Power and to all the, let's say, sister projects for this common organization of the webinar. Welcome, everybody. By the way, I have been working in Ambiente Italia for 17 years, but this year we celebrate our 30 years in the sector of environment. So we are very happy to do that. So I'm coordinating the Enable DHC project together with my colleague, Chiara Lazzari. And let me also thank all the partners that you see in this slide. So basically, the structure, I think, is quite similar to the other project because we have associations like Euroheat and Power. We also have associations of district heating like AGFV at national level. We have, of course, technical partners, and then we have local partners taking care, let's say, of our case studies. I tried to, let's say, to pinpoint what could be our peculiarities, our differences from the other project. We have, first of all, we have 9 case studies distributed in 7 different countries. So we have 7 countries and 9 case studies because we have a double case study, let's say, in both Austria and Ukraine. I think it's very interesting from our point of view that we are covering many different application sectors and that we foresee, at least for the moment, different renewable and waste heat solutions for decarbonizing these existing networks. We also have a wide range of size and age of these networks we are addressing. And I think this is also very important in terms of replication, because we would like to showcase that this decarbonization path is really feasible in many different conditions, and not only, for example, only for old networks or only for large or small networks and so on. And we start from a very good basis of knowledge because we already in the proposal phase, let's say, we analyzed our cases quite in depth. Another peculiarity for us is really the co-creation of these investment plans. So it's not that the utilities alone, let's say, are developing these investment plans, but from our point of view, we really planned a dialogue, an interaction, a cooperation with relevant stakeholders and local and transnational levels. So we will build, and more or less we are at this point, a DHC working group for each one of the case studies. And then all these working groups will be, let's say, brought together, of course, for a knowledge exchange in a working group assembly. So we really tried to institutionalize, let's say, this cooperation. So in these working groups, we will involve, of course, the DHC operators and the key actors of public administration, as well as many other stakeholders. And then also to ensure a replication of our cases, we will also develop 7 policy roadmaps, so 1 roadmap for each one of the project countries. From a technical point of view, we have a couple of relevant technical focuses. Of course, as in the other project, we will develop these investment plans. So we will analyze the financial part, the technical part, and so on. But we have a special focus on digitalization, of course, because you know that especially modern district heating needs to interact, for example, with the electric sector, so with the electricity market prices. And that means that you have to provide these networks with digital solutions which are able to manage large quantity of data. And this is particularly true when you have other devices, like, for example, a heat storage, which can provide additional flexibility to the network. And then we also have a special task in the project, which is about the risk assessment of the investment. So we will try to compare the techno-economic performance of different solutions against uncertainties in several factors, like energy prices or availability, of course, of waste heat from industries, for example, or developments from the demand side point of view, the regulatory and incentive framework, and so on. Okay, these are our 9 cases. Of course, I won't go into details of all of these cases, also because actually we started 1 year after the majority of the projects that they are presenting today. So we started just in September 2024. So as you can imagine, we are really in the, let's say, preparatory phase of the project. But I would like to show you just some hints. I just picked up, let's say, the case studies which have been already promoted in social media and so on, and that's why you see this nice picture. So there was no technical reason, let's say, for choosing these cases. So for example, here you see a case in Ukraine. Of course, you have a very old system in this case, so a very low efficiency one, and it's really a challenge to go towards a modernization and decarbonization of this large system because it's almost 300 kilometers. Then you have in Ljubljana a similar system, and their goal is integrating both waste heat and renewables, also to lower supply temperatures in the network. Then we have some other cases, for example, in Vienna. Of course, in the case of Vienna, it's a very large district heating network, and they already have kind of a plan for the future. So in this case, really the focus would be on the evaluation of investment risk, as I was stressing before. So to test the robustness of their plan against changes, against uncertainties in the future factors. Rijeka, we will be this week in Rijeka for a project meeting, and we will also visit the current district heating network, which is, as you see, really reliant for the majority of its demand on natural gas. And so the goals in this case is to use a combination of waste heat from sewage water for the city, large-scale solar thermal, and also heat storage tanks, again, in combination with the retrofitting of the grid. And then, okay, one last case I wanted to show is a very small network in this case, so less than 10 kilometers long, running mostly on natural gas. And this is a thermal city in the north of Italy. And in this case, of course, also benefiting of what you find from a geological point of view in the underground would be to use heat pumps run on geothermal energy. Okay, and that was all from our side. Of course, as I said, our project just started, but if you want to be informed, the website is already online, so you find it by Googling Enable DHC. And in case you have specific questions, you can email me or my colleague Chiara Lazzari at these addresses you see here. Thanks a lot.
Thank you. Ricardo, thank you very much. Really interesting. And once again, we have come and go, but we each have our own approaches. How do you argue? Many of these projects you're looking at the modernization of very old buildings. How do you argue for this modernization, which takes a lot of time, it's expensive, it's more complex than, say, other alternative solutions, for example, shutting it down and building something new or installing individual solutions, energy communities. So especially when you're looking at the risk, how do you argue for this modernization of old existing networks? You're muted. We're working on the lip reading, but not there yet.
Sorry. I was saying I don't have, of course, a clear answer for that, and I guess this will be quite different from cities to city. But that was our idea. I mean, we are completely aware that this is quite a complex. Even at the planning stage, it will be very complex, and that's why we wanted to introduce in our methodology this involvement of the stakeholders. Because of course there should be the housing companies, there should be the, for example, cooperatives of owners involved in our working groups. And so, let's say, from a technical point of view, of course, we still have to address all the solutions. But from a planning point of view, our idea is really to face this complexity by putting around the same table, let's say, all the involved stakeholders. So it should be not be a project starting top down from the utility, as many times unfortunately is, but really trying to involve all the actors to face and tackle this complexity.
Thank you. Thank you very much. And so if anybody comes up with additional questions for Ricardo, please do write them in the chat or save them for the discussion session afterwards. And as mentioned, for more information, visit the website. So moving on, we will now hear from Marco Cosini, who is here to present the HeatMind DH project. Marco is a senior researcher at URAC Research in Italy and is involved in various European research projects focused on sustainable heating and cooling applications, especially in the district heating sector. He is the coordinator of the HeatMind DH project, who is developing investment plans for the integration of low temperature sources into district heating. But he also has great experience in working with projects supporting energy efficiency in industry and solar thermal. Other research interests he has comprise the coupling between electric and thermal energy sectors, energy scenario design, and energy transitions. So, Marco, tell us a little bit more about the HeatMind DH and the importance of focusing at the investment plans.
Thank you very much, Emilia, for your kind introduction, and thank you to the colleagues which anticipated me. So the HeatMind DH project shares a lot of things, of course, with the projects mentioned before. But at the same time, we are trying to give our own view, let's say, on this subject. In the end, we share the common objective of developing investment plans for a set of case studies, which I'm going to introduce. With respect to the last project mentioned by Riccardo Battisti, we started a little bit earlier, so more similar to the timeline of Set Heat and the other projects presented before, for example, as this project started in September 2023. So we are more or less in the middle of the project, so 1.5 years from start. The project includes 8 beneficiaries, which you see listed here with different competencies. We at URAC are coordinating the project and doing some simulation work. Then we have the University of Zagreb, also an Institute of Technology, Solid, which is an Austrian company with expertise in solar thermal and district heating, Hoch, the Hochschule of Göttingen, Euroheat and Power, which is kindly hosting us today, Noda, a Swedish company specialized on machine learning applied to district heating, and Rise, which, by the way, is the company of Emilia, with a large expertise in heat pumps, district heating, and in this case also in communication and so on. So the target of the project in terms of case studies is to take into account the efficient district heating targets according to the Energy Efficiency Directive. with a horizon of about 10 years that is taking into account the targets for 2035 in terms of needed shares of renewables and waste heat. We have 8 case studies we are tackling, so in 4 countries: Croatia with Karlovac and Vukovar, Germany with Braunschweig and Göttingen, Italy with 2 networks in Milan, a small network called Pompeo Leoni in the center south of the city, and the large network of Milan West, and 2 cases in Poland, Balinek and Szczecin. Each of these case studies are included with the corresponding utilities, which are associated partners of the project. And the final associated partner is Kyotherm, which is a French company providing expertise in financial aspects, which we reveal to be very useful when coming to investment plans. The type of sources and applications we are considering are pretty similar to what mentioned already. Heat pumps will be ubiquitous because our focus is also about low grade, low temperature sources. It was one of the requisites of the call, the live call this project belongs to. So we are also considering wastewater treatment plants, rivers, ground source, and various forms of waste heat, especially low grade. And necessarily heat pumps are a key ingredient of all of this. At the same time, ranging between these different applications, besides, of course, the involvement of utilities and municipalities, we have different stakeholders involved, like wastewater treatment plant managers. We already are in contact with a couple of them, environmental authorities, and of course, the companies owning waste heat. One of our, let's say, key steps in this direction is to prepare maps for all the available waste heat and renewable sources in the cities we are considering. And very recently, we put online what we call a Waste Heat Explorer, hosted by the Austrian Institute of Technology, which is basically the upgrade of a tool developed in a previous project, and where we are now collecting and making available the data for all the cities involved in the project. And you can see the link there. The interface will be updated in the coming months. So if you're going to have a look, be aware that some data might not be 100% precise. There is an automatic mapping behind. But I think this is quite interesting and will enable both to identify specific cases and also to provide an overview about the general availability of this type of sources in these cities. In terms of our general approach, every case study is being tackled with 4 main steps, let's say. I think this will be quite common to all projects, but of course, we start with a general assessment of the existing situation. This has a crucial involvement of the utilities, which are providing data, consumption and production profiles, so that we can really understand what's the starting point of the networks, especially from the point of view of sources, but also in terms of efficiency of the network and so on. Then the second step is the mapping I was basically mentioning in the previous slide. And this takes into account both renewables and waste heat, so that we prepare lists of options for every city. And then, and this is what we basically just closed for every case study in the past month. And we are now tackling scenarios, so a more analysis work supported by modeling, so that we can develop scenarios where we integrate these additional sources, taking into account what is already there, considering possibilities on how to replace fossil-based sources, and also checking the integration hour by hour, so that the merit order of the different sources and then the priorities, let's say, are taken into account. The final step will be the development of investment plans, where all the economic information will be included. Again, with this 10-year horizon. As I said, the target is the 8 case studies I mentioned. Just to give you some order of magnitude, also in our case, we have a lot of diversity, I would say, between the different case studies. so that the energy we expect to integrate ranges from about 4 gigawatt hours per year to 200 in principle, depending on the case study. And if you try to convert this into investment numbers, the range again could be between 2 and 100 million euros. And of course, you can imagine very large cities like Milan and Szczecin can arrive to this impacts if you really want to reach the shares of renewables and waste heat planned by the energy efficiency directive. So that's all I briefly wanted to say. I thank you for the attention. Yeah, and I invite you to check the website. Maybe one quick point, maybe I need the help of the organizers. For this, we are going to have a webinar pretty soon, actually on contracts, which is also a topic we think to be quite important. So on the 3rd of April, we will some of our partners will tell something about like off-balance investments and so on. So I hope you will see the link to register in the chat or in some visible let's say window here in a few seconds. And thank you.
Exactly, and I can imagine. Thank you. There you see in the chat about the event, the Knowledge Exchange Forum about alternative business models. So thank you very much, Marco, for your presentation. People in the group are starting to fall asleep. I understand we've been connected for about an hour, so stand up, shake off a little bit, and please do regular questions, trying to pick them up as much as we can while you think about this, or maybe while you go get a coffee or a glass of water to wake up. What is a crucial point for district heating decarbonization is the identification of sustainable source. Which methodology was planned in the HeatMind DH for low-grade source mapping? Because this is also a very unique aspect of the project.
Thank you, Emilia. Yeah, this is indeed one, let's say, an approach we are proud of, let's say. So it combines some, let's say, manual activities, so to say, with some automatic activities. And that's why we can, let's say, explore quickly wide regions. Of course, automatic mapping doesn't have the accuracy of manual mapping, but still can provide orders of magnitude. So concerning waste heat, we have two different types of approaches. Industrial waste heat, that is really waste heat coming from foundries or any other factory, let's say, requires a list of companies as an input, but just based on very simple data like the industrial sector as specified by the NASE code and the number of employees, we are able to estimate the amount of waste heat based on literature coefficients. Concerning instead what we call urban waste heat, so related to service activities, supermarkets, possible data centers, and so on, we have different estimates. There, everything is done automatically. So maybe with some inaccuracies, as I said, but based on like Google services where tags are available on maps and so on, and we can recognize supermarkets. And then based on the area of these buildings, we can provide waste heat estimates. And finally, the part about renewables is similar, very approximate, but what we do is to identify green areas, parks, and similar, and then to do estimates, again, based on this area, assuming a given technology. For example, for ground source applications, we assume a specific, a standard spacing between boreholes or between aquifer wells, a standard power, let's say, based on typical temperatures, and in this way, we can estimate the amount of available energy.
Great, thank you. And thank you, Alex, for sending your question. As it is for all the three coordinators, I will also save your question for the end, for the general discussion. But thank you, Alex, for your question in the chat. And I believe to the speakers, you can take a sneak peek at the questions we're receiving in. And so you can start preparing your answers for when it's time. But moving forward, with the DH Switch project now will be presented by Marco Calderoni, who is a mechanical engineer with long-term experience in renewable heating and cooling sector. He is technical manager at the innovation consulting company R2M Solutions, who working on EU-funded research projects, research and innovation projects, both on proposal writing as well as project management. He's also the chairman of the Renewable Heating and Cooling ETIP platform. Marco, the floor is yours. It's great to see you on this platform, and please tell us more about the DHC switch project.
Of course. Thank you, Emilia, for the presentation, and nice to see many people connected. I see some old friends. Great to see you, and hope to meet you soon again. So DHC Switch is a very recently started project, financed also in the framework of LIFE. As said, so we started October last year. We'll be working until September 2027. So the project is not much different, at least from the perspective of the grant agreement, to compare to some of the projects we've been looking at before. I'll make it simple, and in the last slide, I also tried to let's say underline the main specificities of the project. Anyway. The main aim is also for us to provide investment plans. The time frame is 10 years. And of course, those investment plans will need or will take into consideration the recent definitions of effective district heating as per Energy Efficiency Directive, and leveraging also on SECAPs if existing. Voila. The partners, I group them. So we have, R2M as the project coordinator, and also we are working on the bankability side. I'll come to this later. We have some technical consultants. Some of the names we've heard about already. Marco Gozzini was talking just before me, and he is also part of this project with, I think, also a similar role. We have a simulation expert, so the project leverages on IES simulation tools and suite for all what is related to the energetic simulation. And then we have Construction 21 from France as dissemination and communication expert. When it comes to the case studies, we have them in as associated partners, and those are A2A, one of the biggest multi-utilities in Italy, bringing in 2 case studies. We have the city of Berglin and the city of Vinkovci in Croatia, and not here because it's not literally an associated partner, the city of Lubatrov in Poland. Then we'll have 5 more case studies. We will also need to collect through an open call, as some of the previous colleagues mentioned before. So, but here it's not yet time, so I'll come back to you as we start working on the open call. Anyway, we'll have 5 further. We call them replicators. The project is divided into 4 phases. We call them links. The first is mapping. And here, among others, URAC is also mapping waste heat. I'm underlining because I saw a question on that by Jacek Bokuczki. Yes, we're also, and I think also other projects are doing that, trying to quantify the available waste heat from industrial processes, so which is indeed often bigger than those that coming from supermarkets or available from supermarkets. We have, but we're also mapping, of course, the demand for coming from new buildings to be connected and potential renewable energy generation. Second phase is modeling. Third phase is assessing the different scenarios considered, and fourth phase is planning the investment. The 5 case studies are, as I said before, 2 in Italy with 30 and 20 megawatt thermal installed capacity respectively, and both look mainly into integration of heat recovery from wastewater treatment. The one in Poland, Lubartów, is a 20 megawatt thermal case or existing district heating network. They're also looking at recovering heat from wastewater treatment, but also at renewable sources, considering biomass soft thermal, of course, connected to thermal storage. And they are interested, so let's say in the wish list, there's also cogeneration to be defined. And the 2 Croatian networks are both 17 megawatt thermal. They're looking into integrating waste heat from wastewater. So you see it's very, very trendy now, but also some renewables, geothermal, biomass, soft thermal, and they're also interested in cogeneration. Of course, these are the technologies in the wish list, and then during the project, according to the results of the simulations and the financial considerations, we'll come up with all or just some of these sources. Which are the specificities of the DHC switch? I mentioned 3. One is has already been summarized by Marco Cozzini before, because he's from URAC and is applying probably this similar methods. Anyway, in a few words, I would say the idea is to use methodologies, validate methodologies, which rely on a limited amount of data, which should be more or less easy to find in every country. That's the idea, to leverage on a relatively simple, not the methodology itself, but at least the data set required to carry out the estimation and come up with good results. Another specificity is that the partner involved in the simulation part, in the energetic simulation part, IS, as I mentioned before, from Ireland, will be developing an investor-friendly dashboard. And this was considered a plus, because of course, then when it comes to investment, and our project focuses quite a lot on bankability, KPIs are essential, must be available at a glance. And finally, bankability is for sure one specificity. Enable DHC, I discovered this morning, also has this in the core. Yes, we're trying to shape the investment plans in a way that those maximize the likelihood to be finally financed. And with that, I think I'm done, Emilia.
Thank you very much. And it is crazy how time really goes by really quickly. One quick question, and I would appreciate a quick answer on your part. Which barriers, other than technical ones, do you see in the process of releasing the investment plans, of realizing, sorry, the investment plans?
Yeah, this is exactly what I was mentioning at the very end, the very last bullet. So this part of, let's say, risk assessment is probably, at least in our understanding, one of the weaknesses we often see in investment plans, not necessarily only in district heating and cooling, but in general across technologies. And let's say the problem is to make the investment plan sound from the perspective of those who have to finance and guarantee. So banks or other financing institutions and public administrations. And we have an expert on that in the company, and our understanding is that often the problem lies in the fact that those doing, let's say, the investment plan and those evaluating it have different backgrounds. So we have investments generally evaluated by economists, while risk modeling typically being carried out by mathematicians or physicians. And for that reason, we'll try to make the investment plans as close as possible to those who have to evaluate it, as best understandable as possible.
Sounds smart, and we look forward to hearing the answers, the results on that, and see if you manage. I believe it's a long-standing challenge and not new, but it'll be interesting to see your approach. So thank you very much. And so last but definitely not least, some people argue that you saved the best for last. We'll see. And we have here the Green Heat Life project to be presented by Evelyn Chen. Evelyn is project lead at Gradient, a company specializing in digital twin solutions for district heating and cooling networks. With extensive experience across the US, Asia, and Europe, Evelyn has deep understanding of the global energy challenges and the role of digital solutions in decarbonization. At Gradient, she helps energy companies optimize their network using digital twin technology, driving efficiency and sustainability. Currently, Evelyn is focused on fostering partnership and integrating smart energy solutions to support the transition to greener cities. So we're really excited to hear about the optimization and investment planning for district heating systems for lower temperatures and decarbonization. Evelyn, what can you tell us about your project?
Thank you, Emilia, for your introduction. Pleasure to be here, and also like as the final presentation of this webinar. And I hope I can still get everyone engaged. So let's just get started. I'll try to keep it brief so we still have some time for question and discussion.
That would be great.
So everyone, my name is Evelyn. I'm the program coordinator of Green Heat Live project, which we're actually focusing on like facilitation of decarbonization investment plan in district heating, which is kind of like very similar to what everybody else has presented already. So I think during my presentation, I will just try to actually keep on how are we going to do it, and then what is the methodology behind our project. So yeah, this one I think we can just skip. So I basically just say this. So before we actually get started into the project concept, I would like to actually present the partners within this program. So we are a consortium with 7 partners. We have our dissemination partner of Euro Heat and Power, and we're partnering up with 5 different district heating operator across Europe. That is SEI Mantova, that's in Italy. We have Klaipėda Energy, which is in Lithuania. We have Aeon, that is a very famous one also in Germany. We have Umea in Sweden, and also Anatolic, that is in the Netherlands. We're trying to actually help this company, or working together to prepare investment plan for decarbonization for a total of 7 district heating networks. So coming to this methodology part, or project concept, we are trying to actually help the company checking, let's say, starting with the feasibility study. So the question is more on, I want to decarbonize my network. So how can I do that? So what are feasible and what are not? How can I check that? And how will my network look like? How is the operation going to look like? How is the saving is going to look like? Or is my network still going to be profitable? So to try to answer all these questions, so to make these partners more confident about their decision, because if it's usually in the infrastructure, it's a really big investment, let's say. So how we're trying to do that is that to divide this project into 3 phases. The first phase will be actually to build a offline digital twin, which I'm gonna explain what is the digital twin later in the presentation. And then using this digital twin to simulate the past operation and future operation of the district heating network. And then from there, we will be able to perform scenario studies. So for example, it would be, if I want to put heat pump to replace some of my power plant or my boilers, is that even feasible? And then how will the district heating network operation look like? And will my network still be like able to provide enough heat to all my customers? And then based on the result, we will work with the district heating companies and our partners together with DHC to prepare a investment planning and the funding plan for all these activities. go to the next slide. Yeah. So just to give you like a very quick, let's say, introduction of what is digital twin, and I thought it would be like really nice to actually give some visualization, so it's like easier to kind of like grasp the concept, as like everybody would have like a different definition of what is a digital twin. So this is the digital twin of one of our partner network. So for a digital twin, we actually will do we'll visualize the whole network, and then we do like a simulation, and then train the model based on past operational data. And from here, you will see we model where the source and the substation, end users, and where each pipes are. Where also you will be able to see the operational data in every single pipe. So here I show let's say just the forward temperature of this one pipe. But apart from temperature, we would have also other like other data like return temperature, forward pressure, return pressure, and heat flow. And it really depends on like what the district heat, what are the requirements of the partners. So with this in mind, I would like to actually show, let's say, past cases that we have already performed with other district heating operator within Europe, just to show like this methodology is practical and then feasible for the project objective that we are working on with Green Heat Life. Since we're actually also a new project, so we haven't actually started with a scenario study within our partner, but I do have like some other real life example that I can show. So just very quickly, yeah. So this is one of the project that we work with a network in Finland, where they have the objective or a plan to phase out two of their coal power plants, and then they would actually need like a solution to actually dynamically simulate the mix of renewable resources to replace all the production of coal power plant. So what we did before, and actually this was already implemented in I think April 2024, and we use the digital twin to simulate how we can remove the coal, like energy production of coal. So you can see on the slide that this amount, like I think is like 4,000 to 6,000 or so. That is a proportion with coal. With the scenario study performed by digital twin, we break this thing into a few different elements that includes biomass, heat pump, oil, and gas. And then we actually can at the end show this is how much each type of sources that you should use to replace the coal power plant, while still keeping your network, say, energy supply safe, and also keep the objective going. And then next slide I would really like to quickly show is another case of shifting from their energy mix by adding a heat pump as one of the production site in the district heating network. So what we do with this network is that we run a So we run like a minute-by-minute simulation for the new heat pumps that they plan to add for 1 year, and then we actually perform a few scenario studies to see what are the best energy mix. On the slide that you can see, the first graph on the left is the actual situation that they have previously, and they have an energy mix of CFG, and 3 boilers. With the digital twin, we were able to see the interaction between different sources, where we give them another, we can give them already the optimization of the energy mix without heat pumps. And while with the digital twin, we then added the other 2 heat pumps to their source mix, and also looking at how they can at which time they should start operating the heat pump at what power, and then give them the optimals with heat pumps. And then I think this was also already implemented in 2023. In this case, the district heating operator were able to actually implement this heat pump and then have a saving of I think 2.7 million annually. And so just to actually show that decarbonization and like a financial feasibility can both be achieved with the simulation study. I guess this is also, I guess I'm already over time. Then happy to actually take questions and comments. Yeah, and last one. Yes, I'll just put a put a QR code here so you can scan and then follow our page, and there you can find all the contact information, and happy to get in contact and connected there.
Thank you very much for your presentation, and great to be able to scan this. We have only a couple minutes left, so I have a question for everybody in the project, and I'd like all the coordinators, and I'd like Evelyn, you to start. So really quickly, in one sentence or two, it's a question from the audience. How do you estimate time to implement waste heat projects? How do you estimate the time from the theory? And it's actually coupled to a question I had for you guys. From the theory, the research, the R&I, to the actual implementation and getting things on the ground, and what do you see are the main challenges there? Evelyn.
Sorry, can I actually have to read the questions again because I had lost the connection for like 2 seconds. Can you repeat it? I'm really sorry.
Yes, of course. So right now we're working with research and development projects, and it's great because we get EU funding and it drives this transition forward in Europe. But this stays in an abstract level. What do you see the challenges and the time it takes to go from the project to actual changes and implementations on the ground with the local energy companies and key stakeholders? How do you evaluate the time it takes and the challenges?
And I think for us, it's because our company actually more focuses on just facilitating the decision and the facilitating a decision, right? And then for us, there's like investment plan is not just just this part, right? You have to work with the local municipality and also house owners and everyone who's involved. And then for that, I think it is the most challenging part because you have to bring all the parties together and everybody has to agree on, like, say, let's give it a go. And of course, this is not the easiest task, I would say. And then this is, I mean, for us, it's like, it's not something that we can do just by our company, right? So,
yeah. And this is why we come together with this type of Synergies Hub, where to answer Alex's question, yes, many of these projects' results will be available publicly. Some are private, as mentioned earlier, because they contain sensitive information. But I imagine that all the project results are available on the project pages, and we'll get together. And I mean, some of them are even key exportable results. So hopefully they will be built upon and used in future projects. But I would like to open the floor to our great speakers and coordinators. Would you have one last word to add before we close this webinar?
Maybe I can add something.
Yes, please.
It's Jacek here. I would like to add something to this question about the timeline for implementing waste heat recovery projects, because waste heat is a very important source of energy that we are looking at. And the answer is not so straightforward because it depends on location, it depends on the municipality and cooperation with stakeholders, etc. So we have projects where such heat recovery can be very fast, like less than 1 year. And we have locations that such projects can last. I mean, development projects since idea to implementation can last for 7 years. So it always depends on the situation. For example, in Gliwice, we are building a heat pump at sewage treatment, and we started at sewage treatment plant, and we started in 2021. And at the moment, we are at the stage of application for permit to build. So it will take another 2 years to develop. So in total, it will be it's already 4, it will be 6. Yes, so it's easy to count.
Great. Thank you for that answer. We have come to the end of the planned webinar. So I understand if most of you need to go and would like to go. So thank you very much for your time and thank you very much for your contributions. Thank you to the speakers. Though I see there's still a couple of hands raised from Dominic and from Marco. So since we agreed at the beginning, those of you who are interested in staying and can stay a little bit longer are more than welcome to do so. We will stay a couple more minutes, but otherwise, once again, thank you. And the recording will be available on the Euroheat Power YouTube and most probably indirectly in all the project's websites. So having said that, thank you for your attention. Marco, you still have your hand up.
Yes, Emilia, I just thought it makes sense to try and reply to Alex Ivancic's question, which now I don't see it anymore. Okay, I don't know why. Oh, okay, Alex, he left. But anyway, I think he touches what I consider to some extent a weak point in new funded research, namely the availability of tools and methodologies. He's asking, okay, but many projects are developing tools. Will those be publicly available? I cannot speak on behalf of the other projects, but what I see in the project I am coordinating is no, those tools are not meant to be publicly available, or at least not all of them, not the majority of them. So I think the European Commission they're not asking for tools to be available, first of all, and they are rather acting at the level of critical mass of utilities involved. So they're financing for some years 3-4 projects every year and trying to build a critical mass, but it's not like they're asking to create a freely available toolbox. So that's the short answer to Alex's question.
So I must say that from the SETHIT project, it's completely opposite, because we are developing a lot of tools, a lot of methodologies that will be publicly available. And already in our webpage, there are many things to be downloaded, for example, guidelines, handbooks, and soon there will be also software tools for quick calculations.
That's great then, and I suggest to somewhat connect those in the Synergy Hub website when it will be possible. So to have visibility at centralized level.
And Marco Cosini, I believe some of the tools being used in HeatMind are also publicly available or
So
open
for
source.
sure, we will make available the results. For example, the maps I was quickly showing is online, so you will access all the data of waste heat for the cities we are developing. Concerning the availability of the tools themselves, we will check. Let's say I don't have now, I think, a final answer, but it's something we are considering for a couple of them. So it's work in progress, I would say.
Okay. I'll take one more question from Sadra. I believe this one was for Evelyn, on how do you simulate, speaking of these tools that are publicly open or not, but these digital tools that are being used to implement the transition, how do you simulate a system? Do you need to connect sensors in different locations to retrieve the data for a period of time, or is it based on physics?
Yeah. So basically, this is it is a bit of both, actually. So the digital twin is usually trained based on the available operational data. So we take whatever a district heating partner have, and then of course there will be like areas where you don't have the sensors, and then there are area that you feel like still black box. So us, it's a bit of a physics modeling and also a bit of experience, actually. So we do work with district heating partners and consultants who are have a lot of experience in this, and then can try to fill in the gap all together with operational data and physical modeling and the experience of like checking, let's say, how old this network is, and then what is a reasonable, let's say, reasonable look of the network, let's say.
Thank you. There's one last pending question that hasn't been addressed directly or indirectly from Anonymous. A quick question to the speakers. Do you have 3 more minutes to answer this, or should we call it a day and then really engage directly with you? We're already 5 minutes over.
I can stay if that's the question.
Great. Then last question. Do any of the presented projects cover the impact of the transition to low-grade waste heat energy sources and corresponding investment plans on the district heating consumer tariffs? So this is about the consumer tariffs. And how might this affect the maintenance of the consumer base of district heating sites? Anybody volunteer to take a stab at this?
I mean, what I
David.
can say about this is that, I mean, in our project, we are not covering this specifically, I mean, maintenance of the consumer base. But I mean, I'm receiving some inputs about this, and we made some research about this also because we presented another proposal a couple of months ago, which was tackling this to the Horizon Europe program. And what I can say is that based on, I mean, not very deep research, but in 7 Central and Eastern Europe countries, the disconnection from district heating is not a big issue anymore. I mean, it used to be a big issue in the past, but not anymore. I mean, some countries, like for example, I think in Romania, they are experiencing more connections than disconnections. However, there is definitely an issue on the retail price of heat regulations, because this could be a very, very important barrier for implementing all these changes. And this is something we will tackle, and we will let's say develop about in our reports, because I think it's a very interesting takeaway of the projects.
Thank you. Marco, I see you had Marco Calderoni. We have 2 Marcos. You had your hand up. Is there anything you'd like to add?
Yeah, well, I saw Marco Cozzini raise his hand, so I thought I leave it to him. But anyway, the thing is, if by low grade, low temperature is meant, which I believe, then I think all of us are touching, in all the projects are touching it, because that was in the request of the call. And of course, we'll then have to consider also the impact on the tariffs. When we move to the economic side of the investment plan. What I wanted to mention is that recently I've started asking myself which will be the future of low temperature district heating, given that heat pumps technology is improving when it comes to the reachable temperature, and high temperature heat pumps are now becoming more common and more mature. So I think this we also have to consider. Will there be, I mean, there will be for sure room for everybody, for every technology, but it's interesting to evaluate how much room there will be for lower temperature renewables if heat pumps can provide a high temperature level and therefore a high amount of the renewable heat at high temperature. That's it.
Really good point. Maybe we have another subject further on, if not in the fall, maybe for the spring. The evolution and the long-term impact of the work we're doing. Marco Cosini, is there anything you'd like to add to this point?
But maybe a simple comment still about tariffs. It's not that we are explicitly calculating new tariffs, but of course it's a boundary condition we have to include. For example, in the case of Croatia, there are publicly fixed tariffs, and that's a boundary. So either you find sources which are cheap enough to comply with those tariffs, or you need to find incentives to make the investment sustainable, so there is no way out. Anyway, for each source we are considering, we calculate the levelized cost of heat, and at least in comparison with individual heat pumps, we are always selecting sources which are more competitive. Then against individual gas or biomass boilers, the situation is more complex, but yeah, costs anyway are always evaluated.
Thank you. Unfortunately, we are 11 minutes over, and I believe we've pushed it a little bit, but I do not want to abuse of the kindness of our hosts and our listeners. So once again, thank you everybody for the really interesting presentations, comments, discussions, and I look forward to continuing. This was the first, but it will definitely not be the last of our webinars. Stay tuned for newsletter, individual events, and much more to come. Thank you.
Thank you, Emilia, for sharing.
Many thanks. Goodbye.
Thank you.
Thank you.
Emilia.
Thank you.
Bye-bye.
Bye-bye,
It was a
everybody.
pleasure.
Ciao.